All right, guys, page number 3, it's like the biggest page, but again, it doesn't require a lot of work, just a few things of the many things that we learned. So number A, we are given circle K, and we're given these measures. On the test, I will not give you a measurement involving pi. I'll give you a regular angle measurement. In this case, this should have been 216 degrees. 216 degrees should have been the measurement. And it is asking us, what is the radius of circle K? Radius. Well, I showed you like 2 different methods to get the radius in class. I'm going to show you one more method that I think it's easier. But it's important for you to have all of the options. Choose whichever is easiest for you. So here's the next method. For that, we're going to be using a formula that I taught you. This formula looks like this. The formula for arc length is equal to theta divided by 360, and that multiplied by 2 pi times the radius. All right, so this is a formula we can use for arc length. We also have the one for sector area. For sector area, so sector area is equal to, again, theta over 360 times 2 pi, times pi r squared. All right, but we're just focusing on this one right now. So this is the formula for arc length. So here's the thing. We want to find radius. We want to find this value here. That's our goal. Let's find what's the measurement of the radius. So for that we need the angle measurement, the given angle measurement, and the given angle measurement is 216. All right, so 216 is the angle they're giving us. So I'm gonna have 216 and the denominator 360. So that is this first part. All right, then the next thing we have 2 times pi. So the pi, I'm gonna make it into 3.14. So 2 times 3.14, and then the radius. It's multiplication, so I can pretty much get each number in its own parentheses. Equals, and the arc length. Do we know the arc length? Of course we do. It's 20 centimeters. It's given to us. So that 20 will be in there. If you notice, I only replaced 2 things, the theta and the arc length. Everything else, it's still the same in the r. So the next thing to do is to simplify this whole thing. Well, first I will simplify my fraction. So in the calculator, let's do 216 divided by 360. And that gives us 0.6. So this piece here is 0.6 times the 2 times 3.14 times the radius. Now let's multiply all of this together in the calculator. That means that we're going to have the 0.6 times 2 times 3.14 times, well, never mind. That's it. So just these 3 values only. 0.6 times 2 times 3.14. Leave the r by itself. Don't do anything to it. It gives us 3.76. 20 equals 3.76. The radius, nothing happened to it. It stays there. Because we cannot multiply radius here. So we want to leave r by itself. Let's divide by 3.76. Divided by 3.76. Cancels out. Radius is equal to 20 divided by 3.76. 5.3. This is my radius. 5.3. So for part A, radius equals 5.3. This is all the work we did we didn't use this, but this is the formula we used, and this is all the work we did to find the radius. All right. Well, now that we have the radius, pretty much finding everything out is really easy. It says use your answer from part A. So let's use this answer. And what is the circumference of circle K? Well, circumference, we know the area for circumference is 2 pi times the radius. So in my calculator, I'm going to multiply 2 times pi is 3.14. That is my pi. Times the radius. The radius is 5.3 equals 33.28. That is my circumference. My circumference equals 33.28. For area, I know the area of a circle is pi times the radius squared. So again, I'm going to make my pi 3.14. That I'm going to multiply it to the radius squared, which is 5.3 squared. So in my calculator, it's going to be 3.14 times 5.3 times 5.3 again, because it's squared. 88.2. That means my area equals 88.2. That's my area. Now I'm going to show you how to do part D. Part D, it's kind of similar. It's using the same radius of circle K. So using your work from part C, what is the area of the sector bounded by points L, K, and M with the central angle to be 174. So pretty much they're giving you the same circle with this is K, this is still L, and this is M. But this time nothing is changing, only the angle. They're changing the angle to be 174. So you can have pretty much the same circle, just a different central angle. Here the central angle was 216. Now they changed it to 174. And they want us to find the arc length of, not the arc length, the sector area, pretty much the area in here. For that, we can use the formula that I showed you before, which is sector area to be equals to theta over 360 times pi r squared. So I'm going to be using this formula to answer this problem. All right, we know that the angle given to us is 174. That's the 174. I'm going to put it in there. So I'm going to have 174 over the 360. That multiplied by 3.14, that's my pi, and the radius squared. What's the radius? We found it like way back. It's 33.28. Oh, wait, no, that's the circumference. Radius r is 5.3. That's the radius. 5.3. And the radius, notice that the radius is 1 being squared. So that's that squared. That's my angle. That's the pi. And that's the radius squared. All right. And we don't know the central angle. We want to figure it out. Again, first thing I would do is simplify this fraction. So my sector area will be, let's simplify that. So it's going to be 174 divided by 360 is equal to 0.48. So 0.48, that is this, times 3.14 times 5.3. I'm going to simplify that 5.3 to be another 5.3. That way I don't put the square. And I'm going to put all of these numbers in the calculator. So I'm going to have 0.48 times 3.14 times 5.3 times 5.3 equals 42.3. The sector area equals 42.3. That is my sector area. So the sector area is 42.3. And that's it for part D. All right, number 9. It says, write the equation of the circle that passes through the point. Sorry for the space there. It passes through 2,2 and is centered at 5,6. So it passes through this point, and it is the center point at 5,6. So for this, I'm gonna give you a grid. We need to find the radius, but just pretty much off the bat, the one center, we would need to graph this and see how it looks. So let's do that. I'm going to use this graph over here to graph my points. So again, the center, we said that the center was at 5,6 and that the point passed through 2,2. So the center is this, 5 and up 6, 2, 4, 5 and 2, 4, 6. There is the center of the circle, and it's going to pass through point 2 and up 2. It has to pass through this point. So that means that we need to find this length. This length represents the radius. Well, as you can see, I'm just going to make this kind of like obvious. As you can see, the length of this, it's not going to be the options that we have here. It's not going to be 25 units. You can see that the radius won't be 25 units. The radius, in this case, it'll be 5. Radius is 5. Just by looking at this diagram here, I can say that my radius is 5. So we have the center and the radius to be 5. That's all we need. We need these two. We don't really care about this point. It just helped us find the radius. Okay? Now, with this, I'm going to use my formula. Remember my formula, x minus x1 squared plus y minus y1 squared equals radius squared. Right off the bat, because the radius is 5 and my formula requires me to square 5, I know that in my equation I should have 25. Radius squared is 25. So I can say E is not an answer and B is also not an answer. I need to have 25. Radius squared is 25. Now here my y minus my y1, and my y1 is 6. Remember, this is my x1, y1. My y1 is 6 squared plus X minus, and it's also positive 5, so that'll become negative 5. This should be the equation I'm looking for. Let's see, I have minus, 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 minus. This seems to be the right formula. D. This one has plus plus, so I know it's not an answer. And this is minus minus, and the radius is 25, but the 5, these numbers are flipped. This should be 6, this should be 5. D is my answer. D is the right answer. I would recommend just do your own formula and check which one matches. Given the equation below, show what is the radius. This is pretty nice. It gives you everything. You don't have to work it out backwards like I showed you. So just find the radius. So if this thing it's already squared, so the square root of 9 will be the radius. The radius will be the square root of 9. And the square root of 9 is 3. That's my radius. My center, so center, should be, remember these numbers switched. So if this is negative 4, my x value will be positive 4. This is the y value is positive 3. That means here it's going to be negative 3. That's my center, and that's my radius, 3. And that's it. And finally, number 11. So it says, complete the square to put the following equation of a circle in standard form. That means this form. I'm giving you this, make it in this form. Then use the equation to identify the coordinates of the center and the length of the radius of the circle. So we need to put it in this form, and then find the radius and find the center. Same way. So for that, as I showed you, let's rearrange the formula. So I'm going to have x squared plus 8x plus, let me leave a square here to put my other number. Then I need to take the y's. Plus y squared minus 14y plus my other number in there equals negative 40 plus those two boxes that I added in the end. 1, 2. So let's see how to do this. So this number here, the 8, two identical numbers that add up to 8, that'll be 4, and 4 plus 4 is 8. This number here will be 4 times 4, 16. That means over here I should also have a 16. Now this one, the middle number again, two identical numbers that add up to negative 14. That'll be negative 7 and negative 7. Negative 7 times negative 7 is positive 49. So this number will be positive 49. That means over here need to have positive 49. All right. So it's time to start going to the next step. Here this was for x. So I'm going to have x, this positive 4 plus 4. Another x plus the other 4. Then plus. Here it's going to be, this is for y, so it's going to be y minus that 7 times y minus the other 7. All of this equal to, we have to simplify now this side. We have to simplify and figure out what is negative 40 plus 16 plus 49. So I'm going to do 49 plus 16 and then minus 40. That gives me 25. I get 25. It's time to go to the last step, which should be taking these two. That's plus 4 becomes squared plus y minus 7 also becomes squared equals 25. Now we have something similar to this. Notice the radius will be the square root of 25, which is 5, and the center will be the x value but switched, so -4, and the y value but switched, so +7. And there you go. There's my center, and there's my radius, and I'm done.